Hello students, today we are going to discuss about temperature measuring sensor. Now temperature measuring sensor is nothing but a sensor which help us to measure a temperature. That sensor we can call it as a temperature measuring sensor. Now we will start temperature measuring sensor with bimetallic strip or thermostat. Now this type of sensor I think you have seen in your iron, means which iron you use to press the cloths. In that the same thing is used. Now how it look? This is the base, and here metal strip is there, and this is not a single metal strip. Along with that, one more metal strip they put. It is attached one, but both metals are different. And at the end of that strip, one iron or soft iron spot or one metal piece is placed over here, and in front of that one magnet is given. Now current supply is given to this point as well as this point. Okay, now one more thing is given here, that is the distance you can adjust. Means if you rotate this, the metal can move over here or it may come back also. Why this is given? Because when the temperature is very less, and if you want to measure a very small temperature, that you can take this magnet near to the strip, or if you want to measure more temperature, you can take this magnet back, or you can say you can increase the distance between them. Okay, now what will happen? First, this metal strip having very low, now this metal is having very low expansivity, and this having very high expansivity. Means what? Means when I heat the metal strip, what will happen? This will expand very less, and this strip will expand more. Now these are placed in the curve shape, and when I heat something, what will happen? This upper metal strip is tried to expand very fast and more. At the same time, this lower strip is not expanding as the higher expansivity metal strip. Now this makes what? This makes the strip get bent, or this trying to bend the strip, this metal strip. And when the metal strip is attached to this magnet, what will happen? The connection will get complete. The connection will get complete, and we can say this temperature, so when we have calibrated this, so we can say this temperature is achieved. And when it is not, or we can say when this connection is not properly getting connected, that time we can say temperature is not achieved as it required. Now next we will learn resistance temperature detector. Here what we do? Here we take a simple resistive element like platinum, nickel, etc., and in the form of coil we use that, and when we heat that, such kind of metals will get increase in resistance as increase in temperature, and that resistance we have to measure with the relation of RT is equals to R naught 1 plus alpha T. Now what is RT over here? It is a resistance at achieved temperature, whatever temperature we are measuring, that RT is nothing but resistance at a temperature T degree Celsius, means whatever temperature we want to measure, that temperature, and R naught is resistance at 0 degree Celsius, and alpha is the temperature coefficient of resistance. Coefficient of resistance. Okay. Now next is thermistors. Now in this, what we do, we measure the resistance again, but this type of metals, if we heat those, the resistance of that metal will get reduced, and we have to measure that resistance. And with relation, how we can measure that? With the relation RT is equals to KE raised to B by T. With help of this equation or relation, we can measure the resistance of such material. Now next is thermocouple. Now in thermocouple, this is the most common device that we use to measure the temperature. And how it works, I'll show you. The two types of materials are taken. This is the one type, we can say A, and this is another type that we can say B. Now near the junction where two metals are connected, near this junction, what we will do, will increase the temperature, we raise the temperature, and as we know, temperature always move from hotter side to colder side. If this side is very hot, it will try to conduct that temperature to the cold side. This will transfer the heat to the another side. That time what we will do, we'll cut the metal, any metal A or B, and we'll take the wires like this. Now at this point we will get EMF, and when we are getting EMF, obviously we are getting the electric signals, and with the help of that, or with the help of how much intensity produced by the thermocouple, we can identify the temperature present at this point, we can determine. This is how thermocouple works. Thank you.